solving the difference quotient. So we're going to put the big division bar with the h and minus sign up top. Behind the minus sign, we're going to put 4x squared minus 2x plus 3. Don't forget, we have to put a parentheses because we have to distribute that negative. Then in front, we're going to do 4 times x plus h squared. Wherever there's an x, we put an x plus h out front. Minus 2 times x plus h plus 3. So I'm going to use some scrap paper because I have to foil this out, do a little extra work. So I have to foil out the x plus h squared. So when I foil that out, that's going to give me a 4 out in front. And x plus h times x plus h is x squared plus 2hx plus h squared minus 2x minus 2h plus 3 minus 4x squared plus 2x minus 3 all over h. Big division bar, sobre h, 4 times x squared, that's 4x squared, plus 4 times 2hx, 8hx, plus 4h a la 2, menos 2x, menos 2h, más 3, menos 4x a la 2, más 2x, menos 3, sobre h. I no longer need a big division bar. I no longer need a big division bar. Notice the negative 3 and the positive 3 will simplify or cancel out. The 2x and the negative 2x will simplify or cancel out. The negative 4x squared and the positive 4x squared will simplify and cancel out. That leaves me with 8h x más 4h a la 2 menos 2h. Muchos h's. A lot of h's. So I can drag out the h. The GCF would be 2h, but I'm just going to drag out an h. If I drag an h out of 8hx, it leaves me with 8x plus 4h. If I take an h out of 4h squared, it leaves me with 4h minus 2. Sobre h, the h's cancel, and my final answer is going to be 8x plus 4h minus 2. If you remember the shortcut, you do not have to do all the work. Now for the derivative, it's sort of like the difference quotient, but we don't need that h in it. So the derivative is just going to be the power rule. 3 times 4, that's 12x, we subtract 1 squared. Minus 2 times negative 7, that's minus 14x. The derivative of 8x is just plus 8. That's our answer because the derivative of 9 is 0. So 12x squared minus 14x plus 8. Number 3, another one, power rule, that's going to give us 10x to the first. And then there's a note for the trig derivatives. So the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of negative sine is negative cosine. The derivative of negative cosine is sine. And their derivatives going down. So the derivative of sine, I just go down 1. That's going to be cosine. So it's going to be 10x plus cosine x. Number 4 is pure power rule. There is no trig identities. So 5 times 8, that's going to give us 40x, subtract 1 to the 4th. The derivative of negative 7 is 0. So my answer for number 4 is just 40x to the 4th. 40x to the 4th. For number 5, I'm going to need my trig derivatives note. So the derivative of sine is cosine. The derivative of negative cosine, go down 1, is positive sine. So plus sine x. So cosine x plus sine x. Graphing, y equals 4. If it's just a y equals, we call that hoi. That would be a horizontal line through y equals 4, whose slope is 0. So I go up 1, 2, 3, 4. Everybody get on the dance floor, and I sketch a horizontal line. Yes, it's a function. It passed the vertical line test. The x-intercept is non-applicable, or DNE. The y-intercept is 4. The domain, it goes to the left forever. It goes to the right forever. We say all real numbers sometimes. Number 7, that's mx plus b. That's a line. So I'm going to begin at 1, 2, 3, 4. Everybody get on the dance floor on the y-axis. My slope is negative 2 over 1, down 2 over 1. Connect the dots as best as you can. Yes, it passed the vertical line test. The x-intercept is 2. The y-intercept is at 4. The domain, it goes to the left forever. It goes to the right forever. This is a parabola because it's squared. I'm going to implement opposite same. So the opposite of negative 3 is positive 3. The same would be negative 1. So I go right 3, down 1. I'm going to use 1, 3, 5. So from there I go up 1 over 1. Up 1, 2, 3 over 1. Up 1, left 1. Up 1, 2, 3, left 1. Now notice, I'm at 3. And I have to go up 1, 2, 3, 4, 5 over 1. So when I connect the dots, that spot there will tell me what the y-intercept is. So yes, it's a function. The x-intercept is at 2 and 4. The y-intercept is at 3, and then I add 5 because of 1, 3, 5. So this here 3 plus 5 would give me 8. Goes to the left forever, it goes to the right forever. Opposite same, it is a square, so opposite same, that would be 2, 2. I go right 2, up 2. I write down 1, 3, 5, but I have to be careful. I can't use the 1, 3, 5 because of this negative 2 out front. So I have to put a negative 2 out in front of my 1, 3, 5. That means it's going to be negative 2, negative 6, negative 10. From that point, I go down 2 over 1. Then I go down 6, which takes me slightly off the graph, over 1. Go back to the vertex, down 2, left 1. Down 6, left 1. Very narrow, upside down parabola. Yes, it passes the vertical line test. It's a function. I have an x-intercept at 1, an x-intercept at 3, and a y-intercept at negative 6. Domain, it goes to the left forever. It goes to the right forever. So I only have the graph that I'm grading. We're going to use extra graph paper to do all 3 of the graphs. We're going to do all 3 of these graphs separately, and then we're going to bring that answer over here. We're going to put that answer instead of here. We're going to put it here. So our first graph that I'm going to graph is x plus 5. So I'm going to write down y equals x plus 5. So I begin at 1, 2, 3, 4, 5. And my slope, if I mx plus b it, I begin at 5, and my slope is 1 over 1. So from there I'm supposed to go up 1 over 1, but it takes me off the paper. So I have to reverse my program and go back in the other direction. So now I'm going to graph negative x plus 1 down here, negative x plus 1. That's this graph, negative x plus 1. mx plus b, I begin at 1 on the y-axis. My slope is down 1 over 1. Down 1 over 1, down 1 over 1, down 1 over 1. Go in the other direction. My third graph is 1/2 x minus 2. So I'm going to put that third graph up here. Third graph is 1/2 x minus 2. So 1/2 x minus 2. mx plus b. I begin at negative 2 on the y-axis. My slope is down, up 1, right 2. Up 1, right 2. There's that graph. Now, for graph number 1, I need the domain restriction. And the domain restriction says x is less than or equal to negative 2. So x is less than or equal to negative 2. I'm going to go over to negative 2, go up to the graph. I put an open circle there. Do I fill that circle in, or do I leave it open? Because there's a line under it, I leave that circle open. Oh, I close that circle in. I don't leave it open. Arrow points to the left. I'm only interested in that piece going off to the left. I'm going to copy that piece up here on my graph paper. I'm going to copy that piece up on my graph paper. So I go left 2, up 3, left 2, up 3, close circle, down 1, left 1, down 1, left 1, down 1, left 1, arrow going out away from it to the left. My next graph, I have to bring this domain restriction over. X is between negative 2 and 2. So on this graph, I want to do x is between negative 2, and 2. So I go over to negative 2, I go up to the graph, I put an open circle there, and notice, there's no line under it, so I leave it open. I go over to x value 2, go down to the graph. Notice, there's no line under it, so I have to leave this open. X is between negative 2 and 2, so I'm only interested in this zone that's between negative 2 and 2. I'm going to copy that over here on my graph. So I go left 2, up 1, 2, 3. Left 2, up 1, 2, 3. Open circle and a closed circle. Notice, you shouldn't even be able to tell that there's anything wrong with that or different. I go over 2, down 1. I go over 2, down 1. Open circle. The array of points is down 1 over 1. Down 1 over 1, down 1 over 1, down 1 over 1. Open circle. The third graph is 1/2 x minus 2, but x is greater than or equal to 2. So I take this domain restriction and I put it over on this graph. X is greater than or equal to 2. So what we're going to do for this one, we go over to x value 2. We go down to the graph. There's a line under it. So we know that one stays closed. Arrow points to the right. So I go to 2, negative 1. I go to 2, negative 1. And a closed circle and an open circle is allowed. That's okay. That's legal. And then the array of points is up 1 over 2. F of x is continuous. A closed circle and an open circle makes it continuous. An open circle and a closed circle makes it continuous. Notice, it's darkened all the way across. So for 13, we're going to do 3 graphs. And we're going to bring them all together on this graph. So this first one for number 13 is y equals 3. That's a horizontal line. So y equals 1, 2, 3. Negative x plus 1. Negative x plus 1. So mx plus b, I begin at 1 on the y-axis. And then my slope is down 1, right 1. Down 1, right 1, down 1, right 1, down 1, right 1. Go in the other direction. My third graph, 2x minus 2. 2x minus 2. mx plus b. Begin at negative 2. Y-axis, my slope is up 2, right 1. So from there I go up 2, right 1, up 2, right 1, up 2, right 1. So now I want to bring all 3 of these graphs over to this graph. My first graph has the domain restriction, x is less than negative 2. So x is less than negative 2. Let's go over to negative 2, go up to the graph. It's going to be an open circle because there's no line under it. Arrow points to the left. So I'm going to graph this. I'm going to go to negative 2, 3, negative 2, 1, 2, 3, open circle, and an arrow pointing out to the left. Next graph, negative x plus 1. The domain restriction is x is between negative 2 and 1. X is between negative 2 and 1. So I'm going to go over to negative 2. It's a closed circle. Line under it. I go over to 1. It's a closed circle. Line under it. X is between. I'm only interested in this spot that's between those two. So I go to negative 2, 1, 2, 3. Negative 2, 1, 2, 3. A closed circle and an open circle is allowed. I go to 1, 0. Closed circle. The array of points connecting them is down 1 over 1. So from there, I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. Third graph, domain restriction is x is greater than 1. So x is greater than 1. I'm going to go over to the graph at 1. It's going to be an open circle. Arrow points to the right. So I'm only interested in the piece going off to the right. So at 1, 0, it's an open circle and a closed circle. That's okay. Then going away from that, I go up 2 over 1. Up 2 over 1. Once again, f of x is merely continuous. There's nothing fancy going on. F of x is continuous. Number 14. Again, I'm going to use my extra graph paper. I have y equals 4. I have y equals negative 2x plus 2. I have y equals the square root of x minus 2 minus 2. All three of those graphs, I want to graph on separate graph paper and then bring over to this graph. So number 14, 4, that's Hoy, y equals 4. I go up 1, 2, 3, 4, and sketch a horizontal graph. Negative 2x plus 2, mx plus b. It's a line, so I begin at 2, and my slope is down to right 1. For square root function, we implement opposite, same, opposite, same, opposite, same. Right 2, down 2, pop a dot. We use 1, 3, 5, but it goes right, right, right. Let's go to the domain restrictions. So for number 14, the first domain restriction is x is less than negative 1. X is less than negative 1. The second domain restriction, x is between negative 1 and 2. And the third domain restriction, x is greater than 2. So our first graph, we're going to beat up and place in that first graph. So we go to negative 1, go up to the graph. We put an open circle there. There's no line under it, I don't believe, so it stays open. And it opens to the left, so I'm only interested in what's going off to the left. The next graph, we got to copy this graph down. So I go left 1, up 1, 2, 3, 4. Left 1, up 1, 2, 3, 4. Open circle, arrow pointing out to the left. Next graph, domain restriction, x is between negative 1 and 2. So on this graph that I graphed from the second equation, I graphed over here, and now I'm going to beat it up. I go over to negative 1, it's an open circle because there's no line underneath the inequality. I go over to 2, 1, 2, I go down, that's an open circle. Does that make you... I'm going to take this and move it over. So I go left 1, up 1, 2, 3, 4. So I'm going to go left 1, up 1, 2, 3, 4. An open circle and an open circle is okay. I go right 2, down 2, right 2, down 2, another open circle. The array of points connecting these two is down 2 over 1, down 2 over 1. Down 2 over 1, down 2 over 1. Connect the dots as best as you can. Third graph is the square root function. Domain restriction is x is greater than 2. So if we just look at this closely, we'll notice that if I go over to 2, I go down to the graph, it's an open circle. And it goes out of there to the right. So I go to 2, negative 1, 2. So I go right 2, down 2, and it's an open circle and an open circle. That's allowed. The array of points is 1, 3, 5, up 1 over 1. Up 1 over 1, 2, 3. This is not continuous. It has one removable, another removable. So f of x has 2 removable discontinuities. Equals 1. Y equals 2. Y equals 2. Y equals 3. Y equals 3. Let's get our domain restrictions. So the first domain restriction is x is between 1 and 2. So the first domain restriction, x is between -1. Oh, I'm sorry. X is between, this is number 15. X is between 1 and 2. Close circle, open circle. Go over to 1, close circle. Go over to 2, open circle. X is between. So I go to 1, 1, close circle. I go to 2, 1, open circle. Connect the dots. Next domain restriction, x is between 2 and 3. So x is between 2 and, whoops, no line under it, 3, no line under it. So I go over to 2, 1, 2, up to the graph, I put a closed circle. I go over to 3, up to the graph, and I put an open circle. So from 2 to 3 is there. So I'm going to copy this down on my graph. I go to 2, 2, and 3, 2. 2, 2, close circle. 3, 2, open circle. Y equals 3. Domain restriction, x is between 3 and 4. So x is between 3 and 4. Again, I messed up. No line under it. So I'm going to go over 1, 2, 3, up to the graph. It's a closed circle. I'm going to go right, 3, 4, open circle. So at 1, 2, 3, 1, 2, 3, 3, 1, 2, 3, close circle, open parentheses. If you were Mario, you would jump once, twice. So f of x has 2 jump discontinuities. Discontinuities. Number 16, I'm going to try to do right on the graph.
Opposite same, so I'm going to go to -4, +1. 1, 2, 3, 4, 1. I'm going to implement 1, 3, 5. So from there I go up 1 over 1. Up 1, 2, 3 over 1. Up 1, left 1. Up 1, 2, 3, left 1. Domain restriction, x is less than -2. So I go over to -2, I go up to the graph, that's an open circle, it says. Next one, mx plus b. I begin at 1. My slope is down to right 1. Now notice as I come over here, I go up 2, left 1, and it's an open circle there. So that's an open circle here. Open circle and an open circle. Go over to 1, that's an open circle. Opposite same, so that's going to be 1, 3. I go right 1, up 1, 2, 3. Pop a dot, it's a closed circle. The array of points coming out of there is 1, 3, 5, but I go up 1 over 1, up 1 over 1, 2, 3. So that's a removable, that's a jump. F of x has 2 . discontinuities, one removable at x equals -2, one jump at x equals 1.